Hello, it's Professor Garb here with a Unit 5 review. These questions are taken from Hawks, and I'm going to go through them one at a time. This is pretty much a summary of your Unit 4 review. It's Unit 4 review. It's kind of Chapter 5 plus 10.1 is what we're going to be doing today in class. So besides Section 10.1, this is Chapter 5, which is the Unit 4 review on your syllabus. So let's get started without any further delay. Here we go. So they give us a function g of x is equal to 2 to the x, and they have to map which function, which graph goes with that function. Well, the best thing to do there is to put in a 0, maybe put in a value that you can recognize. And the pictures on Hawks actually have coordinates marked off here. I'm just writing it on a pad, but I'd put in 0, 1. If you put in a 0, you're going to get 2 to the 0, which equals 1. So you know it has to go through 0, 1. You go here, it goes through here, it does not go through here, it goes through here, and it does not go through there. So you know it has to be between these two functions. But then this is an increasing function, right? As x gets larger, right? So 2 to the x gets larger. So it has to be an increasing function. So therefore, it can't be this one because that's decreasing function, so it's got to be this one. Moving on. The next function is talking about value of an asset, where the original cost is here for C, R is the amount it reduces, the rate it reduces every year, and T is the number of years. It might be something like a car, or some type of equipment that reduces in value, depreciates over a period of time. These are the variables that you're given. So we're using this formula right here, and they're asking us, what are they asking us? They want to know, find the value after 3 years. So it's like when you drive a car off the lot, you lose like 20-30% right away. Same kind of thing. So you start off with 1897. You do 1897. And then you put in 1 minus, so I'm going to put in 1 minus. It's going to be 0.7 to the third power. You put that on your calculator. See if you can do that here for you. And you should get 0.7. Can you see that? Yes, you can. To the third power. Bring it down. Times 1897. And we get our answer 650.61. We have to round that off, so it's 650.67. 650.57. That'll be your answer for that one. Next problem here, number 3. Without using a calculator, find the log of 1,000. Well, remember, if we're not mentioned otherwise, if it's not mentioned otherwise, this is base 10. So that means 10 to what power equals 1,000? So 10 to the first power is 10. 10 to the 1. 10 to the second power is 100. 10 to the third power is 1,000. So therefore, this is going to be 3. So it's going to be 3 here without a calculator. That's what you're asked to do, and you can check it afterwards, but it's definitely going to be 3. This one says find the log of 16 to the 1/2 here. Well, that means, again, changing from log form to exponential form, the base is 1/2, so it's going to be 1/2 to the what power equals 16. Now, you might be able to do that in your head, but just in case you're not, just remember you can take the log of both sides. So you could say the box, bring down the exponent, x, right? So you're going to say x times log 1/2 is equal to log 16. And it doesn't matter whether you use natural logs or not. And you can say x is equal to, so you can say log 16 over log 1/2. That'd be the way to solve it if you didn't know. So I'll put that on the you're allowed to use the calculator in this one, I believe. But we'll do it without a calculator also. So that's going to be log 16 divided by, and you get -4. So -4 is your answer. But you also know that you can change this to both powers, so you can change this to the same base. That's going to be 2 to the -1 to the x is equal to 2 to the 4th power. That's another way to do that. And you say, okay, so therefore -x is equal to 4, so x is equal to -4. So there's more than one way you can do that problem there. I just want to break that down for you. Number 5 says solve the equation. Let's take a look at that one. Oh, I didn't even write the equation down. So 5 says, this one says 6 to the 3x minus 7 is equal to 1 over 36. 6 to the 1 over 36. Okay, so I would change these both to base. You want to write these with the same base, okay? Because if the bases are the same, then the exponents are going to be the same. So this means you have 6 to the 3x minus 7 is equal to 6 to the -2, because 6 to the +2 equals 36. So if I make that negative, it's going to be 1 over 36. So therefore, I'm going to have 3x minus 7 equals -2. And then we get 3x is equal to 5. And that leads us to x is equal to 5 over 3. Sorry for the small writing there, but that's what it is. So again, you want to get the same bases there. So that changes to 6 to the -2 power. And then you could equate the exponents if the bases are the same. And then you add your 7 and divide by your 3. So number 6 talks about bacteria. And you have 275 bacteria at the beginning. And every 31 minutes, the population quadruples. And we want to know, find an equation that works for that. Well, the equation that models that would be a population is equal to 275 to start out. Your base has to be 4 because you're quadrupling. Now, since you're quadrupling every 31 minutes, well, the time could be any number of minutes. So you can't put 31 power because that'd be like that wouldn't be right, because we don't know what our number of minutes are going to be. So it's the number of minutes divided by 31. So because every 31 minutes it quadruples, not just any number of minutes, right? Not every minute. It doesn't quadruple every minute, but every 31 minutes. So if t is 31, it's going to be 4 to the 1st power. If it's 62, it would be 4 to the 2nd power. So this represents it correctly because every 31 minutes. So the number of minutes divided by 31 is the number of times it quadruples. So let's use this to find the population in 2 hours. Well, if that were the case, so again, it's not 31 only because that would be that it's quadrupling every minute, and that's not the case. So the population is going to equal to 275 times 4. Now you have to change that 2 hours to minutes. That'd be 120 minutes over 31. And you do it on your calculator. And if you do that, you're going to get 275 times, and then 4, no, it's out of view, don't worry, to the 120 divided by 31. There you go. 275 times 4, okay, and hit equal, and there's your answer. So it's going to be 5,880. 58,869. What am I talking about? 58,869. Round to the nearest bacteria. That's what they want. Now here for number 7, what they want us to do is you have to equate these. So equate the basis is what I would do. So I would say that I would make this 3rd power and make it -1. So it's 3 to the -1 to the 4x plus 4 is equal to 3 to the 3rd to the x, and then you equate the exponents. So you're going to get -4, distribute the negative. -4x minus 4 is equal to 3x. So then you're going to get -4 is equal to 7x, and x is equal to -4 over 7. That's the way that I would attack that one. This is a nested problem. You have to do the log on the inside. So it's the log of, now I'd bring this 500x down. So it's log of 500x times the log of 100. Because we know the log of 100 is going to be 2. So this is going to be the log of 500x times 2, which is the log of 1,000x, which is, remember using the product rule, the log of 1,000 plus the log of x, which will give us 3 plus log x. There you go. Now this one, number 9, deals with the deer population, and it's given by this formula, and we want to know the doubling time, so how long is it going to take to double? Well, to double, you'd say it's equal to 1260, so 1260 is equal to 630, 2 to the t of 3, so if you divide this out, you're going to get 1 is equal to that. So you're going to get 2 is equal to 2 over t over 3. So since 2 is just 2, it's 2 to the first power, so 1, since the bases are the same, 1 is equal to t over 3, so therefore t has got to equal 3. Now for number 10, we have to expand this expression. Do we have a part 2? Let's see. I thought there was a second part, so we have to find when's the population equal to 5,040. That's what they ask us. So we would say 5,040 is equal to 630 t to the t over 3. So if you divide out both sides by 630, you're going to get 8. 8 is equal to 2 to the t over 3. And again, you want to get the bases the same, so it's going to be 2 to the third equals 2 to the t over 3, which means 3 equals t over 3, which means t equals 9. Now this is the one you want to express out. And so in this case, you want to take out a common factor. That's how you can simplify it. So it's going to be log, and you take out 25. It's going to be 25 times 2x plus 5y. Because log of 5 to the 25, you know I can write that using the same base. It's going to be log 5 of 5 squared, because you want to get log of a to the b, because that's equal to 2. Okay. Log of 5, so and then you rewrite it like this: 2x plus 5y, and this is going to be 2. So this is going to enable you to take out a 2. It's going to say 2 plus log of 2x plus 5y. There you go. Now number 11. And number 11, you want to write this as follows. So you want to write this using a base. You can say 3 to the what power is equal to the 4th root of, this is going to be 9. So therefore, you want same base, you can say 3 to what power is equal to 3 squared to the 1/4, right? Because you want to write this with the same base. So it's 3 to what power is equal to 3 to the 1/2. So therefore, x is equal to 1/2. Again, getting the same base is key there. Now you want to invest $2,300 for 5 years. You want to say which account's going to be better. Well, we can know right off the bat that if we do 1 plus 0.0291 over 365, if you're making a higher percentage and you're compounding it daily, then you're definitely going to make more than another account that makes a lower percent, and that's only compounded annually. So without even doing any work, we know that that this one's going to be greater. But I'm just going to write out what it would be. It would be 1 plus 0.023 to the 5th power. So obviously this one's going to be bigger because it's a higher percentage and you're compounding it more frequently, so check. Don't need to do any more work there. This one's saying without a calculator, evaluate as a fraction. Was the log of 8 base 1, so that means 8 to what power is equal to 1, so therefore x has got to be 0 in order for that to work. That's the only one that's going to work. This one here, they ask us to condense, so we have to put this together using more than one rule. So this is the product rule here, so it's going to be ln of 6 plus 9, ln of 6 plus, let me say it this way, ln of 6 time, and then this one's going to change, so this is going to be and this is going to be x to the 9th, because you're bringing that 9 back up, right? And then this one's going to be y to the y to the 5th, but since subtraction goes to the denominator, so it's going to go down here, it's going to be y to the 5th. So therefore, this whole thing is going to be ln of 6 x to the 9th over y to the 5th. So here you have the product, because you're adding. You bring the 9 up using the power rule reversed, and you bring this 5 up using the power rule reversed. And that's what's happening there. Okay, so that's our final answer for that one.